Hello, good afternoon my dear students. Welcome to one more amazing session from Sri Chaitanya Academy Infinity Learn NEET YouTube channel. So we are here re-rise for NEET. So NEET examination was conducted and it has been cancelled. So let us not discuss about why it is cancelled, how it has happened. Now only one option we have, re-rise for NEET examination. So take this as an opportunity so that we can re-attempt the examination with double enthusiasm. For that, Sri Chaitanya Academy Infinity Learn NEET YouTube channel always try to help you to reach your dream medical college. You are all with us. So let's start the session. आज हमारा सेशन में thermodynamics and equilibrium, chemical equilibrium and ionic equilibrium एक ही सेशन में फटाफट करते concept you are going to revise it. So those who are online, please like the session, share with your friends, subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. So what about your Josh? How you're feeling? And just I want to give you a few important tips before going for the session. Don't read anything new. Read the things you already completed. Just revise it smartly. Expert Leon, hi. 606 आशमा. So एक बार like button दबाओ. Let's start thermodynamics. So I don't want to give any introduction, I don't want to give any derivations, I just wanted to give you just a formula recapture and important noteworthy points. Take a pen and paper and do the things and write the formulas once in a paper, so ताकि आपको एक राउंड रिविजन भी होगा, है ना? Yes, I know, especially for NEET exam preparation students, thermodynamics and physical chemistry जब आता है ना डर भी लगता है ना. So no worry about this, I am going to help you with that. Okay, hi, how are you? Just those who are online, please like the session. Thermodynamics, you can see thermodynamic process, in a process, a system from a state to another state is changed, and that operation is called as thermodynamic process. The thermodynamic processes are various types. Isothermal process, the process that takes place at constant temperature, dt is going to be 0, right? And isochoric process, the process that takes place at constant volume, is called as your name expect. Okay, my name is, what is your name? Expert Leon. Okay, so dV is equal to 0. Okay, and isobaric process, so the process that takes place at constant pressure is called a isobaric process. That process has a dP is equal to 0. And moving ahead, adiabatic process, and the process that takes place at constant heat is called as the adiabatic process. Bachcho, this is very important. People will have the confusion about adiabatic process and isothermal process. So the main difference between this isothermal process and adiabatic process is, isothermal process is a process that takes place at constant temperature, means it can exchange heat with its surroundings. Okay, so isothermal process, the container or the vessel, whatever, is kept in a thermal thermostat. Okay, and adiabatic process, the process which cannot exchange heat from the surroundings, so it is kept in a thermostat, it is kept in thermally insulated container, it is kept in a thermostat. Okay, so that is the major difference between isothermal process and adiabatic process. बच्चों समझ में आ रहा है क्या? सब्जेक्ट में अगर कुछ डाउट है ना तो आप चार्ट बॉक्स इस्तेमाल करो, and we can have a genuine discussion about the subject in this YouTube channel. We are not promoting anything here, just simple genuine subject is being delivered. So for any queries, you can just click the links that is available in the description box, so that it will be definitely helpful to you. Bacho, you can see IUPAC is sign conversion of the heat and work. You can see energy contained in the system. If heat is released by the system, it is going to be negative. You can see it is a negative. Some दिखाई दे रहा है क्या बेटा? S, okay, and work done by the system, it is going to be negative. If you see in the positive and the negative is different versions in physics, but this is according to IUPAC. So in chemistry, we adopt this convention. and work done on the system is going to be positive, and heat absorbed by the system is going to be positive. So देना है लेना है, अगर देना तो नेगेटिव, लेने तो पॉजिटिव. So just keep this thing in your mind so that you never confuse about that. I'm pretty well sure if you have a question you can do it, but the options are tremendous and it is going to be turbulent. Sometimes same answer positive negative में देता है, कौन सा magnitude में लेना है आपको confusion है. And you can see first law of thermodynamics, you can see system internal energy. I will explain you here. This is your system. Initially मान के चलो इसका internal energy U1 था, इसका ऊपर कुछ काम कर दो, so work is done. Simultaneously heat is also given, Q is also given, ताकि इसका internal energy U1 से U2 तक बदला. So बदलने के बाद U2 is equal to U1 plus Q plus W, right? So you can say U2 minus U1 is equal to Q plus W. U2 minus U1 is equal to delta U is equal to Q plus W. This is the mathematical version of the first law of thermodynamics. You can say delta U is equal to Q plus W or Q plus or minus W. ये क्या चीज़ है? अगर work is done on the system, W is equal to positive. Work is done by the system, W is going to be negative. Are you getting or not? बच्चों, clear? Now moving ahead, calculation of a heat. Calculation of a heat here. The total heat capacity CT is equal to dQ by dt and joule per degree centigrade. Hi, say thumbs up and fire emoji, everybody, those who are online, so that it's a live interactive session, it is not a radio session, right? Not a recorded session. But moving ahead here, molar heat capacity. So heat capacity, the amount of heat supplied to a specific amount of the substance to increase its temperature by 1 degree. So it is of two types, so specific heat capacity and molar heat capacity. Specific heat capacity is the amount of heat supplied to 1 gram of the substance to increase its temperature by 1 degree centigrade. Whereas a molar heat capacity is the heat that is supplied to 1 mole of the substance to increase the temperature by 1 degree. So you have CQ by N delta T, okay, and joule mole inverse Kelvin inverse. This C is of two types, CP and CV. Molar heat capacity at constant pressure, molar heat capacity at constant volume, that also I just want to give you. CP is gamma R by gamma minus 1, CV is equal to R upon gamma minus 1. Moving ahead, specific heat capacity, just now I explained you. In next slide, I just want to give you the difference relation between the CP and the CV. So please write these formulas, and you are not asked to calculate big numericals based on these formulas. Rather, you will be asked to just find at least formula based concepts are required. So relation between CP and CV. CP minus CV is equal to R, and CP minus CV is equal to R, I said, molar heat capacity at constant pressure minus molar heat capacity at constant volume, and gamma is the ratio of the CP and CV, and it could be in the different ways. Gamma is equal to CP by CV and CV plus R by CV and 1 plus R by CVM. And CV is equal to R by gamma minus 1, that I wanted to say. CP is equal to R gamma upon gamma minus 1. So these are the things. Gamma is the Poisson ratio for diatomic molecule, triatomic molecule, monoatomic molecule. So triatomic molecule, you can say it's a polyatomic molecule. R value is going to be 0.0821 liter atmosphere mole inverse Kelvin inverse, and R value is equal to 8.314 joule Kelvin inverse mole inverse, and R value could be 1.986 calorie Kelvin inverse mole inverse. you can take this value as R value nearly taken as 2 calories, Kelvin inverse, mole inverse. So depending upon the dimension you are solving the question, you can get, okay, EZVRI. You understand this? You understand this, bacho? So moving ahead, you want to make a note or take a screenshot, that's up to you, you can do it. Fine. And you can see work done. So isothermal reversible expansion and compression, that is going to be W is equal to minus nRT ln V2 by V1. Okay, you can also say W is equal to 2.303 nRT log V2 by V1. You can directly take this. Reversible and irreversible isochoric process. For isochoric process, dV is equal to 0, ताकि work done is going to be 0. Hi. Moving ahead, reversible and irreversible isochoric process, that's what I mentioned here. Reversible isobaric process, W is equal to P delta V. Based on that, you might have done this V2 minus V1 here, V2. This is a final and this is initial I wanted to show. Or you can also say W is equal to P external, that is important, and delta V. And based on this, the NEET happened May 3rd, one question has been there, right? 7-6, what is that? One question has been there, right? So like that, these formulas are the formulas which exactly it has to be used, you need to know it. Fine, clear, bacha? Moving ahead, that's what I want to say. Adiabatic reversible expansion. T2 V2 power gamma minus 1 is equal to T1 V1 power gamma minus 1. Fine. So use these sessions, this is very important and you can do the best. If you have any doubts, please let us know. Now moving ahead, reversible work, W is equal to P2 V2 minus P1 V1 upon gamma minus 1. And PV is equal to nRT, therefore you can say nRT2 minus D1 upon gamma minus 1. Fine. And also R is a gas constant, P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, V2 is the final volume, right? N is the number of moles. Okay, very good. And for irreversible adiabatic, you can say W is equal to P2 V2 minus P1 V1 upon gamma minus 1. So that one is taken as nRT2 minus T1 upon gamma minus 1, nCvT2 minus T1. My name is Suresh, Faculty of Chemistry from Sri Chaitanya Academy, Infinity Line NEET YouTube channel, right? You can use when P external V2 minus V1, that is delta V, you can use for this P1 V1 by T1 is equal to P2 V2 by T2. Fine. Moving ahead, if this kind of questions are there, very important for NEET examination. Bacho, graph ke basis it is given. So this is a PV graph, pressure versus volume. When a system is changing from PA to PB, so point A to point C, and it is going to be C to B, okay, so A, B, C, D. So work done that is calculated from here to here can be calculated. So work done can be calculated by taking, this is a process from here to here, and here this is a volume is constant, dV is constant, work done is going to be 0. When the pressure is a variable, work done is going to be area of shaded part. Always keep this thing in your mind. Work done in the PV graph is always equal to area of the shaded graph. For this, work done can be calculated. The PV graph may area under shaded graph. That can be given work done here, area under AC curve, that is AC curve, and plus area under CB curve. So that is given as AC is 0, area under CB curve is equal to 0 plus area under rectangle BCDE, that is BCDE. So by taking this, you can say BC into D and C is going to be V2 minus VA into external pressure PA. So based on that, you can do it directly. Are you getting or not? Clear? So if you could be able to handle this kind of questions, graphs, you can do the best. And why don't you get rank number 1, all India rank number 1? I don't want to just criticize that. So all India rank number 1 is not an item that you are deserve to get it here. You want to just end up at 10,000, 20,000, it's not your goal. You are an awesome student, you can get the best, right? Why don't you get number 1? So by attending simply in the YouTube sessions, can you clear NEET examination? Yes, you can clear NEET examination simply. You can be topper as well. आप सही सुना, right? Okay. Now दूसरा graph पकड़ लेता हूँ मैं. In that consider A, C, A, B and C and C, D, E. Now work done from the state 1 to state 2. This is the state 1 and this is the state 2. Are you getting or not? And this can be done by AB curve. You have a rectangle and you have a triangle. You have a rectangle and you have a triangle, right? So area of the triangle, area of the rectangle, you can say. So work done is going to be, work done from 1 to 2 is going to be area of the triangle ABC plus area of the rectangle BCDE. For that, triangle area का formula निकाल of BC and AC plus BC and DC, you are going to get of VB minus VA into PA minus PB plus VB minus VA into PA. So like that you are going to get questions, isn't it? Are you ready to do one question based on this? Take a pen and paper, everybody write it. So what will be the work done in this AB process? I am waiting for your answer. What is your name? 7684. I am Dr. Suresh, Faculty of Chemistry. Okay, come on. Pressure and volume. So will you give the answer you want me to give? So use the chat box and tell the answer. You do it and I am going to solve it. So it is coming, the pressure in atmosphere 24 is given and the volume is given, 26 is given, the meter cube. And first let us say W from A to B. So it is asking about the work from A to B, from here to here. So I have to take this and I have to take this, connecting these two, area of the triangle and area of the rectangle. Ready? So area of the triangle, so half into 6 minus 2 meter cube into 4 minus 2 ATM. Length of the base into length of the perpendicular plus 6 minus 2 meter cube into 2 minus 0 ATM. So on doing so, what is our answer? I am going to get 12 ATM meter cube is the answer. Option A is the correct answer. Perfect, perfect. So the question looks maybe complicated. The answer comes in different 3 steps. You practice like this only. Practice makes man perfect, right? Are you ready to do one more question here, bacho? Right. So work done during the expansion of a gas from volume 8 meter cube to 16 meter cube. Again is the external pressure of 5 atm. P external is equal to 5 atm. So work done is equal to negative P external expansion now and delta V. So minus P external V2 minus V1. So minus 5 into 16 minus 8. So that is going to be the answer. How much? Minus 40 meter cube is the answer. Fine, clear? Any doubt? So moving ahead, free expansion, external pressure is going to be 0. So the work done is going to be 0. So if you see the application of the first law, when you study thermodynamics, you can say energy neither be created nor be destroyed, it can be converted into one form to another form. If some quantity of one type of energy is disappeared, same quantity of another energy should appear, right? So like that, delta U is equal to Q plus W, delta U is equal to Q minus P delta V, because W is equal to minus P delta V. So you can use this. Are you getting or not? So thermodynamics is a concept which is very simple. You can handle it, no problem. And majority of the students who are just rushing towards the NEET examination, whenever physical chemistry comes, especially thermodynamics, I know that you give the very least priority, which is actually not correct. You have to aggressively work on these formulas, can do it. So constant volume process, okay, so Cp minus Cv is equal to R here, constant volume process, internal energy you have to take, okay, for constant pressure process, that is enthalpy you have to say. So you can say delta H is equal to delta U plus PV. You can also say delta H is equal to delta U plus delta nRT. So enthalpy is mathematically, it is equal to internal energy plus PV work done. Okay, Ramunyanka. Fine, right. Now moving ahead, second law of thermodynamics. It says enthalpy, entropy of the universe increases. Okay, so delta S universe is equal to delta S system plus delta S surroundings should be greater than 0 for a spontaneous process. The process which has a self urge to proceed by itself is called as a spontaneous process. And entropy is dq reversible upon temperature. I wanted to say a system A and a system B. Carefully you say. It has 0 degree centigrade initially, it is have 25 degree centigrade. Now I wanted to give you delta S1 SA1. Okay, so if you give 5 joules of energy, okay, it is going to be A2 ban gaya, entropy change. Okay, entropy change. So and 5 joules of energy is given, entropy is increased, है ना, इसको भी 5 joules of energy is given. So yes, B1 से yes B2 तक पहुंच गया, right? Now मैं क्या बोलना चाहता हूँ उसमें, this is what is called delta SA and this is what is said delta SB, है ना? ये दोनों में क्या अंतर है? Sanyatesh, okay, I actually really don't remember. Could you just tell me when you attended the classes from here? Okay, Sanyatesh, okay. So मैं क्या पूछना चाहता हूँ here, ये दोनों का क्या relation है? I wanted to say delta SA should be greater than delta SB, ताकि इसे टेम्परेचर कम से एंट्रोपी इंक्रीज ज़्यादा से ज़्यादा होगा. सो आर यू गेटिंग और नॉट बच्चों? होप यू अंडरस्टैंड दिस कॉन्सेप्ट. क्लियर? दैट्स परफेक्ट, राइट? दिस इज वेरी इंपॉर्टेंट. लेट अस मूव अहेड. नाउ, so entropy calculation for an ideal gas undergoing in a process. That's perfect. Okay, let's see. From state A, P1, V1, T1, irreversible process. So that state B tak पहुंच गया, P2 V2 T2 तक, that is the state 1 and P V T are the state functions. And delta S of the system is equal to N CV ln T2 upon T1 plus N R ln V2 upon V1. So only this is applicable for an ideal gas. Okay. Moving ahead, Gibbs free energy. It's a state function and extensive property. Extensive property means additive property. You can add the delta G values. Okay, so delta G is equal to delta H minus T delta S. This is what is called as Gibbs-Helmholtz equation. It tells about the criteria of spontaneity. Hi, Naresh, Rahula, right? So delta G is 0, the system is at equilibrium. If delta G is greater than 0, the system is going to be non-spontaneous. If delta G is less than 0, the process is going to be spontaneous. Okay, this is very important. Based on this, at this level, based on this current slide, definitely you can expect one numerical, let it be a numerical theory oriented questions you are going to get from the NEET June 21st. I say Re-NEET. So क्या program चल रहा है अभी, क्या program चल रहा है, Re-Rise. Okay, first of all, in this Re-NEET program, the major thing that decide your rank is motivation. जो पढ़ाई किया, जो preparation किया, हो चुका, but at this level main ingredient in your career right now is the motivation. So never leave that. Fine. Moving ahead, standard free energy change, delta G naught is equal to minus negative 2.303 RT log Kc, equilibrium constant. At equilibrium, delta G is equal to 0, so Kc, Qc become Kc here. The decrease in the free energy gives as negative G is equal to work done, net work done is equal to 2.303 nRT log V2 upon V1. So delta G for elemental state is equal to 0, delta G for delta G products minus delta G reactants. Okay, bacha, clear? Moving ahead, thermochemistry. So chemical reactions and the heat exchanges during chemical reactions is studied in thermochemistry. Here you can change in standard enthalpy. You can say delta H. We know that for reactant gives rise the product. Sum of the enthalpies of the products minus sum of the enthalpy of the reactant. So this is the situation you can see. If product is greater than reactant, you can say it is an exothermic process, and if the reactant is less than the product, it is an endothermic process. Reaction will be exothermic as well as endothermic, that's what I just want to say. So for exothermic process, delta H and the reaction progress, it goes like this, and delta H versus reaction progress, it goes like this. Okay, this is the reactant and this is the product. It is going to be exothermic process. This is the reactant and this is the product. This is endothermic process. समझ में आ रही क्या? Fine. Moving ahead, temperature dependence of delta H. For a constant volume reaction, delta H2 is equal to delta H1 plus Cp T2 minus T1. This is what is called Kirchhoff's equation. Delta Cp is equal to Cp of the products minus Cp of the reactants. And for a constant volume, E2, internal energy 2 is equal to internal energy 1 plus integral delta C1 CV and dt. So this is a constant volume process. So all formulas, what not is, everything is written here. Talking about enthalpy of reaction from enthalpy of formation. So what is enthalpy of formation? The enthalpy change when 1 mole of the product, 1 mole of the substance is formed from its elemental substances. So delta H of the reaction is equal to sum of the enthalpy of the standard enthalpy of formation of the products minus standard enthalpy of formation of the reactants. In that, you can say standard enthalpy of formation of the elemental substance is going to be 0. Okay, so that's what I want to say. Estimation of enthalpy from the bond enthalpies. For that, enthalpy of reaction is equal to enthalpy required to break the reactant into the gaseous atoms minus enthalpy released from the products from the gaseous atoms. During a chemical reaction, reactant is converted into the product. In the reactant, the old bonds has to be broken, and the product, the new bonds has to be established. Understand? And the resonance energy also you can calculate. So, and resonance energy is enthalpy of formation experimental minus enthalpy of formation calculated. Okay, and that is enough. You can do it. And let us talk about some. This is the end where thermodynamics recapture is done. Anybody has any doubts, please let us know. So that let us talk about a chemical equilibrium. So अगले सेशन में हम आयनिक इक्विलिब्रियम में ला सकता हूँ. Okay, with a limited period of time, you are going to do all the available concepts and well, let us solve it. So for a reaction, A plus B gives rise C plus D, and given A plus B, rate of according to mass law of mass action, rate of forward reaction is equal to rate of a reaction is directly proportional to the active masses, the product of the active masses whose terms are raised to their power of stoichiometric numbers, right? So for this is a forward reaction, for this is a backward reaction. So forward reaction is directly proportional to A and B, backward reaction is directly proportional to C and D, and the ratio of this forward reaction constant and the backward reaction constant is called as the equilibrium constant. Okay, so K equilibrium constant is equal to rate constant of forward reaction, rate constant of backward reaction. This is very, very, very important. Fine, any doubt? Now moving ahead, in terms of the partial pressures also you can say. So partial pressure A, B, C, D. Partial pressure of C to the power N1 dot partial pressure of D to the power N2 upon partial pressure of A to the power M1 into partial pressure of B to the power M2. Now how Kc and Kp are related? I just want to say Kp is related as a Kc. So Kp is equal to Kc RT to the power delta N. What is delta N over here? Delta N in the gaseous state, you can say sum of the number of moles of the gaseous products minus sum of the number of moles of the gaseous reactants. Okay. Now in that, if delta N is equal to 0, Kp is equal to Kc. If delta N is less than 0, Kp is less than Kc. If delta N is greater than 0, Kp is greater than Kc. Are you getting or not? Are you getting or not? And that's what is possible values of K. Possible values of K. If K is equal to 1, the product concentration, reactant concentration बराबर होता है. K is greater than 1, product concentration, reactant concentration से dominate कर सकता है. And K is less than 1, reactant concentration dominate करेगा product concentration का ऊपर से. Okay, as K value increases, stability of the product increases and the stability of the reactant decreases and the time to reach the equilibrium decreases. That's very, very important. If you are not able to see the arrow mark direction, you can just take this as a marker. So you can have a eye capture catchy type questions based on this. If you have any doubts, please let us know better. But you're moving ahead, effect of temperature. The value of equilibrium constant changes with a change in temperature. So that is given as log K2 upon K1 is equal to delta H, negative delta H upon 2.303 R, 1 by T2 minus 1 by T1. Okay, and this is what is called Van-'t-Hoff equation. Fine. So I am Bengali medium student. Okay. So I teach here only in Hindi and English. Okay, fine. So moving at the value of equilibrium constants is independent of the following factors. So this can help you to talk about the NEET examination. MCQs directly you can get it from here. So it initial concentration independent में and the presence of a catalyst and the direction from which the equilibrium is reached. Okay, इंडिया बंगाली क्वेश्चन पेपर में ट्रांसलेट गलत करेगा, ऐसे नहीं होगा बेटा. And also presence of inert material, and also you can say these are the 4 points. But किस चीज में डिपेंड करेगा? Okay, but it depends on temperature. That is very, very, very important. Okay, moving ahead, the reaction direction you can say the Kc value, if it is greater than 10 cube, you can say reaction always favors in the forward direction. And if it is less than 10 power minus 3, the reaction always favors in the backward direction. Hardly आगे बढ़ने का कोशिश करता. But you can see 10 power negativity 10 power 3 बीच में होगा तो the reaction appreciable amount of forward and backward reactions takes place. So you can judge the extent of reaction based on the Kc values. Okay, and talking about the concentration quotient QC. So the concentration quotient QC is just like Kc expression only, but the condition varies. So the QC and Kc are same. The magnitude of the QC and Kc tells you. I will tell you here, if QC is equal to Kc, reaction is at equilibrium. If QC is greater than Kc, reaction favors in the backward direction. If QC is less than Kc, reaction favors in the forward direction. Are you getting or not? Right? That's what diagrammatically I just want to show you. Clear? Any doubt? Okay. Moving ahead here, Le-Chatelier principle. If a system is subjected for a stress like change in concentration, temperature, pressure, volume, whatever, the reaction is going to be disturbed at the equilibrium. So that the equilibrium has a natural tendency to re-establish its equilibrium. This is what is called as a Le-Chatelier principle. So change in concentration. If increases the concentration of the reactant, reaction always favors in the forward direction. And if the increase in the concentration of the product, the reaction favors in the backward direction. And also bachcho, if each pressure change, it is a simple trick I just want to say. If it's a simple trick, if delta N is equal to 0, pressure change has no effect. If delta N is a negative, if pressure increases, reaction favors in the forward direction. If delta N is going to be positive, if pressure increases, reaction favors in the backward direction. Are you getting or not? And change in temperature, endothermic process and exothermic process. Increase in the temperature, exothermic process, backward direction. Increase in temperature, endothermic process, forward temperature, right? And that's very important here. I just want to say trick here. Okay, in introduction of inert gas, introduction about the inert gas. In this inert gas, if you apply at constant volume, so delta V is equal to 0 and constant pressure, so here no effect. Okay, for this condition you have to say, for the reaction delta N is going to be negative, the reaction favors in the backward direction, delta N is going to be positive, the reaction favors in the forward direction. If delta N is equal to 0, has no effect. So like that you can have various combinations, and this is how we are done from our side. Okay, so in the next class we talk about the ionic equilibrium and one round preparation of these NEET formulas and the concepts will be done. Hope you love this session. Please share with your friends. Subscribe to Sri Chaitanya Academy NEET Infinity Learn YouTube channel and stay tuned and press the bell button so that आगे आने वाले के sessions भी आपको पता चलेगा. Okay, I am done from my side. We'll see you more. Thank you very much. Bye bye.